Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. I'm Alex. Join me with Area in the latest Deep Dive by Defense Report, where we provide sharp, no-nonsense breakdowns of the latest in global defense news, military technology, and strategic developments. And today we are unpacking one of the most critical and frankly provocative rumors coming off the Ukrainian front lines. We're talking about the potential integration of cutting-edge laser weapons onto Ukraine's largest unmanned ground vehicle, the Protector.
This is a monumental story. It's not just for Ukraine, but for, every military strategist in NATO. Because if this integration is confirmed, it confirms something absolutely pivotal. Directed energy weapons, or DoDWs, have officially moved from that theoretical future warfare idea right into immediate frontline reality.
And we've had hints of this before, haven't we?
We have. We already know Ukraine claims to be one of the very first nations to successfully use a laser-based anti-drone weapon in combat. The very secretive Tryzub. Exactly. And now we are talking about putting that high-speed, deadly, and incredibly cost-effective capability onto a mobile ground platform.
Onto the Protector.
Right. This convergence isn't just a tech upgrade. It's a radical shift. It's fundamentally changing European defense planning, all while driving toward one core goal: redefining risk by removing human beings from situations that have no right to fall on living bodies. That's the real mission here.
Okay, let's unpack that mission, because this whole conversation about robots is really being driven by one thing.
The drone war.
The drone war. The conflict in Ukraine is without a doubt the first full-scale drone war. UAVs are central to literally every tactical function, from reconnaissance and spotting for artillery to, those thousands of cheap but lethal kamikaze attacks.
And that pervasive threat, that constant swarm, has forced the defenders to adapt faster than anyone ever predicted.
That's how are they doing it now, before lasers?
Well, it's an adaptation that requires layers. There's no single silver bullet. Ukraine's current strategy is this fascinating blend of high-tech and, you could say, low-tech.
Okay.
On the heavy metal side, you have your kinetic defenses. Things like the Western-supplied German Gepard self-propelled anti-aircraft guns.
And frontline troops love those.
They do. They're constantly praised as the single most effective weapon they have against the Iranian-made Shahed drones.
The Gepard is phenomenal, but it's a big, expensive system. It needs its own logistics.
It is, which is why it's supplemented by mobile fire teams. These are highly trained, agile units using heavy machine guns and man-pads, things like the Stinger and the Polish Pyron missiles.
And they're effective.
Incredibly. They account for a huge portion of success, something like 40% of all drone shoot-downs. But that's still just the hard kill layer.
And we know hard kill isn't enough, especially against more advanced threats.
Yeah.
So what about the electronic warfare side?
That's the silent force multiplier. Ukraine is fielding the Atlas network. You should think of it as this comprehensive digital mesh.
Okay.
It links thousands of sensors and jammers together to create what's essentially a unified anti-drone wall right across the front. It gives them real-time awareness and, more importantly, the ability to jam threats up to 8 kilometers away.
That layering is crucial for just staying in the fight. But this brings us to the core economic problem, the thing that makes this shift to lasers so necessary. It's the cost crisis.
It's the terrible exchange rate. That's the economic imperative driving this whole pivot.
I mean, conventional munitions are just too expensive to be shooting down cheap drones all day.
Exactly. When you look at the figures, the math is just staggering. We are often talking about firing a precision munition that costs, say, $25,000, or often much more.
At a target that might cost $50,000? $100,000 if it's a bit more advanced.
Right. You are nearly breaking even, or in some cases, you're actually losing money on the intercept itself.
Which means the attacker can just keep up the pace while the defender burns through their stockpiles and their budget.
Precisely, and that's why DDWs change the entire calculus. Lasers offer a negligible cost per shot, essentially just the cost of fuel or electricity.
And a very deep magazine.
Virtually unlimited ammunition. It's only constrained by the platform's power supply. For the first time, this means the defender can achieve economic parity with the attacker in a drone war. That is a massive strategic advantage. Which brings us to the UGVs themselves. The rapid expansion of robotization in Ukraine, it's all rooted in this clear, pragmatic doctrine of tactical expediency.
Simple logic.
If a machine can take the risk instead of a person, the machine takes the risk, period. And this philosophy, learned under intense fire, is resulting in astonishingly fast development on the battlefield.
It really is a testament to the speed of necessity.
Yes.
So let's talk platforms. What about the smaller systems like the Ravlik, which I believe means snail?
The Ravlik is a classic example of this rapid development. It's a 6x6 robotic soldier platform, pretty lightweight and around 500 kilograms.
But it can still carry a decent payload.
It can. It's got a 200-kilogram payload capacity, or it can haul up to 2 tons on a trailer. But the crucial thing is that it was combat tested even before the full-scale invasion.
So we had a head start.
A huge one. It allowed developers to immediately optimize its control systems for resilience against electronic warfare. In an environment defined by jamming, a robust comms link is that robot's lifeblood.
Okay, and that brings us to the start of today's deep dive, the Protector. This is not a small machine. It's described as a heavy, multi-role robotic pickup designed for this new era.
Yeah, the Protector is really built for endurance and a heavy payload. It has a substantial 700-kilogram payload capacity and a full weight of 3,000 kilograms.
Wow.
It's designed to operate independently for long stretches, too, with an operational range of 400 kilometers on roads. But here's the spec that really matters for laser integration.
It's communication.
Its robust comms system. It lets it maintain contact with the operator at distances over 15 kilometers.
15 kilometers. Why is that specific range so tactically critical?
It's the difference between life and death. That range allows the human operator to stay well outside the common range of Russian counter-battery fire, standard jamming zones, and often even beyond the effective range of their tactical recon.
So the UGV takes all the risk.
The UGV performs the high-risk, forward-deployed tasks, while the human remains in relative safety.
So if the Protector is the workhorse, what are these high-risk missions they're already doing? What does the source material say?
Well, they're performing these essential but often invisible engineering and logistics missions.
So not just fighting.
Not just fighting, they carry food, water, batteries, the basic things that keep a forward unit running, but also incredibly dangerous engineering tasks like clearing mines or retrieving damaged equipment, all under fire.
And installing fortifications.
Exactly, installing defensive things like hedgehog coils, often in the face of direct enemy observation. They even have an aggressive role. We're seeing reports of them executing remote strikes.
How so?
Delivering several dozen kilograms of explosives to fortified positions where, the common FPV drones just lack the power or the range to get in there and do real damage.
So using them for remote, heavy strikes and engineering under fire, that drastically reduces the exposure of your infantry. It's revolutionary risk management.
It is.
And meanwhile, we see Russia scrambling to keep pace.
Absolutely. The race is fully on. Russia has pushed systems into serial production, like the marker UGV.
What can that do?
That platform has AI specifically geared toward air target destruction. Its machine gun turret is incredibly fast. It can rotate at 350 degrees per second.
Essential for tracking small, fast drones.
Right. And they also have the Impulse PVO UGV, which uses these small kinetic interceptor projectiles to go after recon drones.
So this intense competition brings us right back to the most advanced capability yet, the directed energy leap. We're moving past machine guns and into pure energy weapons. Let's talk more about Ukraine's domestic laser, the Tryzub.
The Tryzub, or Trident, is a deeply guarded program. Specific technical details are very scarce, and no verifiable images have been released.
But officials are confirming it's real.
They are. They've repeatedly confirmed that the system is real, and crucially, that it's currently operational.
And its primary mission is to neutralize that low-cost drone advantage.
That's its entire reason for being. It's reportedly deployed to zap low-flying Shahed drones at a range of about 2 to 3 kilometers. If they're doing this successfully, they are joining an extremely elite club of nations.
Okay, here's where we need to apply some critical thinking, though. The rumor is putting this tech, which needs a huge, stable power source, onto the Protector UGV. That vehicle is already carrying a 700-kilogram payload. The challenge with lasers is always power generation and, thermal management. Can a vehicle this size realistically carry and sustain that? Or is this rumor just a bit premature?
That is the pivotal question. It's the known engineering hurdle for all mobile DUW platforms. However, the global trend suggests this convergence is the immediate next step. The engineering problems are being solved as we speak.
And the strategic benefits are just too big to ignore.
They are. DWs revolutionize the engagement chain. The energy is fired at the speed of light, so there's no lead time, no flight path to calculate. And as we said, the magazine is practically unlimited.
You also mentioned the concept of a graduated response. Can you elaborate on why that's so important for a ground robot?
Sure, a graduated response gives you tactical flexibility you just don't get with a missile. A missile is a final all-or-nothing decision.
Right, destroy.
A laser beam, because you can modulate its power and focus, lets you tailor the effect. You can use a lower setting for non-lethal effects, like temporarily blinding a sensor or a comms link.
Without destroying the asset.
Exactly. Or, if you need the hard kill, you just keep the beam focused on a vulnerable spot, an optic, a control surface, until the target is incinerated. It offers a tactical nuance that kinetic weapons just can't match.
And this global context, it really does seem to support the rumor. Ukraine isn't alone here.
Far from it. The UK recently tested its Dragonfire laser weapon with great success. The U.S. Army is actively deploying 20-kilowatt-class laser systems on vehicles like the JLTV.
And Israel.
And Israel is investing heavily in a future laser wall defense. This global commitment confirms that mobile, ground-based DUW systems are the immediate strategic direction. We even have commercial examples being tested. The UGV DUW partnership is already being proven.
So the battlefield necessity in Ukraine is driving innovation at an exponential rate. But we should broaden the context here. This conflict has also exposed critical defense manufacturing gaps across all of Europe.
It's been a very painful lesson. The acute need for counter-UAS systems and just rebuilding munition capacity has triggered an industrial mobilization.
What are some examples?
Take Norway. The government earmarked close to $100 million just to help small and medium-sized companies work directly with Ukrainian forces.
On what specifically?
Of expanding production of explosive material, creating new production lines for rocket motors. It's a direct industrial response to what's needed on the battlefield.
And the challenge of sustaining basic artillery production, specifically 155 millimeter shells, that was maybe the starkest supply chain problem of all.
Absolutely critical. The war has forced a shift from just buying from stockpiles to actually creating indigenous supply chains. We saw a major step here when Ukraine's defense industry entered a joint venture with a U.S. firm.
Right, D&M Holding.
Their goal is to produce 155mm artillery propellant in the U.S., with production starting in mid-2026. This is about securing the fundamentals of the fight for the long term.
And while Ukraine innovates with these potentially low-cost laser solutions, Europe is also buying established high-cost kinetic systems to protect its own airspace.
That procurement drive is massive. The Netherlands, for instance, ordered a two-digit number of Rheinmetall's very capable Skyranger anti-drone cannons for under €1 billion.
And those were mobile.
They're intended for both mobile vehicle deployment and stationary defense. Meanwhile, Belgium ordered Saab's advanced Giraffe 1X radar and handheld drone guns from Drone Shield. These purchases are a clear sign that the lessons learned in Ukraine are now dictating European defense spending.
So we've covered a huge amount of acceleration today. We started with the simple reality of the drone war and the unsustainable economics of kinetic defense. That drove the necessity for robotics like the Protector to save human lives and for directed energy like the Tryzub to save money. And now these two necessities are converging.
Into a mobile, autonomous, laser-armed platform, Ukraine, out of pure battlefield necessity, is driving the pace of technological adoption for the entire world.
And that necessity is forcing a revolutionary change in how we even think about frontline engagement.
It is. The integration of UGVs like the Protector with agile laser systems ensures that autonomous machines can execute hard-kill counter-drone missions far forward, completely removing the human operator from immediate danger.
Which brings us to a final thought.
Right. This accelerated move toward mission autonomy raises a really important question for military planners everywhere. It's not just about the tech itself, it's about this. How quickly can allied nations adapt their slow, deeply entrenched acquisition cycles to field these combat-proven technologies, like the Tryzub concept, before the next generation of cheaper, faster, and more autonomous threats arrive?
So the speed of institutional adaptation, not just the technology, is the new competitive edge.
That's the bottom line.
You've been listening to Defense Report by Alex and Aria, where we analyze the latest in military strategy, global defense, and advanced weaponry. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. We'll catch you next time.